Hi everyone, happy Saturday, and it's time for Ask a Scientist. The two questions tonight I've got are about electricity. What is electricity? And the second question is about what is the difference between ice and water. And believe it or not, these two are slightly kind of related, okay? So first up, what is electricity? And basically, electricity is it's a natural phenomenon, okay? It is defined as the flow of electric charge. And this charge is carried by these little particles that make up atoms. So my first prop, very technical, a little picture of atoms, okay? So this is a picture of neon, okay? So this is a neon atom. And basically in the center of an atom, in the middle bit, this is called the nucleus. And inside here you've got protons that have a positive charge and neutrons that have a neutral charge, which is why I've drawn them as 0. And all around the nucleus of an atom, you have got these things here, okay? So these are called shells. And this is basically how electrons move around outside an atom. And these little X's are how we draw electrons in these shells. And you'll notice in the first shell, we only have 2 electrons. And in the second shell, we've got 8 electrons in these little pairs of 2. And all electrons have got at most 2 electrons in their outer shell or in their inner shell, and 4 pairs of electrons or 8 electrons in their subsequent shells. Okay, no matter how many shells it has, it will have a maximum of 8 in its outer shell. So it's these electrons that can become a little bit loose, okay? So they're called free electrons or delocalized electrons. And basically, whenever you have an electron that kind of comes loose from its shell and can kind of float around, and it's not necessarily attached completely to the atom anymore, these electrons can move around. And because electrons have got a negative charge, if they move around, they carry that negative charge with them. And that's essentially what the movement of charge is, okay? And it can be regarded as being a positive charge or a negative charge. And if it's a negative charge, it's due to the flow of these electrons. And electrical charge can be static, like the static you get in your clothes if you rub a balloon on your hair or anything, or it can be dynamic. And that dynamic charge is what we generally call electric current, and what we would use at home in your appliances whenever you're plugging something into the wall or using batteries or something. And it's very similar to magnetism. So electricity and magnetism are actually very similar because they're both to do with the movement of these electrons. And if you look at a battery, for example, you'll see that one end of a battery has a positive charge and the other end has a negative charge, okay? And this end is where essentially the electrical charge comes from. And I say essentially because if you study science or GCSE science, this is kind of a part of what is involved in the electricity part of the syllabus, okay? So here's my next prop. An electric current. And this is essentially how you would draw a very basic electric current. These little bits at the top are what we call cells, and 2 cells joined together would make a battery. And you can see one of them has a positive charge and one of them has a negative charge written beside it, just the same as a normal battery. So this is how a battery would be situated if this was a real circuit. And then this little circle with an X down here is a bulb. And conventional current, which was kind of first recognized by Benjamin Franklin, he assigned basically anything that did the work, he assigned that a positive charge. So he assumed then that the flow of electrons went from the positive end round to the negative, and that's what we call conventional current, or the flow of electricity went from the positive to the negative. Since then, we have found out more about electrons, and we know now that actually electrical current and electrical flow is due to the flow of these negatively charged electrons. And actually the current goes from the negative round to the positive, which is the opposite of conventional current, which is regarded as being positive round to negative. So if you're looking at circuit diagrams or checking out anything about electrical current, you'll see conventional current. And in that case, that's to do with the this kind of mixed up version of electrical flow. And just because it was used for so long and in so many different ways, and everyone kind of assumes it, and it was never changed. Everyone just decided, okay, you know what, we'll keep it like this, even though technically it's incorrect. Overall, it kind of balances out because the flow of negative electrons is the same as the flow of the positive charge through the protons, although protons themselves don't actually move. So that is electricity. It is the flow of electric current carried by electrons as they move around something. And that's why metals are really good conductors of electricity, because metal atoms have got lots and lots and lots of those free electrons. So it's very easy for electrons to move inside a metal compared to something like a plastic or wood, in which case they don't have these free or delocalized electrons, so they can't move, they can't pass that charge along because the electrons themselves don't move. Okay, and that brings me to the next one, water and ice. So what's the difference between water and ice? Well, the only difference is how they are in their physical state. Okay, so chemically they are essentially the same thing. They are made up of molecules of hydrogen and oxygen, and I've got my kids Lego here to help me out with this one. So here you can see we've got an atom of oxygen, and at the top these two little red blocks are two atoms of hydrogen. Okay, so oxygen is also known as H2O, and it's because you've got two hydrogens attached to one oxygen. Okay, and whenever they're attached like this, we call this a molecule, and this is a very basic molecule. It is one molecule of water, or H2O, and these bonds, okay, these Lego bricks are attached together really, really, really strongly. Okay, so it's very hard for them to move apart. If you have got gas or gaseous water, which is water vapor, which is what you have when you breathe out, or if you boil water, the kind of steam that comes off, okay, they are water molecules that have got nothing really holding them together anymore. So they will float away into the sky and kind of spread out and take up all the space. And that is gaseous water or water vapor, steam. And if you've got liquid water, you've got lots of water molecules that are kind of stuck together. Okay, so I've got 4 water molecules here, and they're together, but they're kind of loosely attached. So they won't float away from each other, but they're not completely stuck together either. And it means that if you move them around, they'll take the shape of whatever their container they're in. So if you have a glass or a jug or a vase or whatever, if you pour water into that, it will just take whatever shape is there. And that's why we can make lots of different kind of shaped ice cubes, for example. If you're going to freeze water, then you're going to cool it right down. And when you do that, the little bonds that attract the water molecules together become much stronger, okay? And these little bonds, this is what this green block is, okay, are essentially going to cause these water molecules to stick together so tightly that they're stuck together and they don't move, which is what you can see whenever you have got water molecules stuck together to make ice, okay? So here you can see these are stuck together, and now they will only fit something that is going to be that shape. No matter what way I hold them or move them, they won't change shape, okay? So now this is regarded as a solid because it's very strong. It doesn't change shape. It has its own specific shape, and it won't change to take up the shape of whatever the container is. So this is what happens when we make ice. And the bonds then, these green bits that hold these water molecules together, are so strong that the water molecules can't flow apart from each other or can't float away from each other. And that happens at around 0 degrees. So 0 degrees is known as the freezing point or the melting point of water. If you get up and you heat it again, what you'll do is you'll break these bonds and you'll start to form liquid water again. So if you go above 0 degrees, you're making liquid water, and they can move around again. And if you go way above 100 degrees, okay, or the boiling point or condensation point of water, then they will become loose gaseous molecules again, and they will start to then flow away. So that's the difference between solids, liquids and gases in terms of water molecules, or H2O specifically. Have a good weekend.